Okay, we're going to continue to talk about circles, but in circles we're going to focus on chords within a circle. A chord is a segment with endpoints on a circle, so let's look at the two blue circles on the right, and they both have chords. Let's call this A, B, and CD. What's the difference between chord AB and chord CD? Well, obviously chord AB passes through the center. We'll call that C. And when a chord passes through the center of the circle, we call it a diameter. It is the longest chord. What a diameter does for you is it creates two semicircles. So here are our semicircles, and we'll just write semicircle. In contrast, a chord that is not a diameter will create a major arc and a minor arc, and you can pretty much figure out just even by eyeballing which one the major arc is and which one the minor arc is. So take a guess. What do you think this one is? I think it is major, and we will talk about the definition of major and minor arc. So here we go. Let's choose that color, and this is a minor arc. Alright, now let's discuss when two chords are congruent. And this theorem here says that in the same circle or in congruent circles, two minor arcs. So let's look at this minor arc and let's look at this minor arc. And what we are saying is that arc AB is congruent to arc CD if and only if chord AB, and we know it's a chord when there's a straight segment sign on it. So if the chords are congruent, the minor arcs are congruent. Let me just label this minor arc. Okay. Next theorem. If one chord is a perpendicular bisector of another chord, so one chord, so let's look at the chord that's bisecting the other one, and that's SQ. Then the first chord is a diameter. So we can conclude from here that SQ, segment SQ, is a diameter as it bisects chord TR perpendicularly, and that perpendicularly is important. And we can write this in an if-then form also, but as long as you get the gist of it. And let's also indicate that this is a diameter as it passes through the center C. Okay. This is the converse of the previous theorem. And here, if a diameter of a circle is perpendicular to a chord, the diameter bisects the chord and the arc. So that means these two will be congruent, and these two arcs. Minor arcs are also congruent. Let's write that in the language of geometry. So we are saying segment DH is congruent to segment HA, HF, and arc DG is congruent to arc GF, and that is because we're given that EG is a diameter, we're given that it intersects segment DF at a right angle, therefore it bisects segment DF and minor arc DF. Next theorem. In the same circle and congruent circle, two chords are congruent if and only if they are equidistant from the center. I want you to pay attention here. The diagram shows at the moment that EG and EF are perpendicular to chords CD and AB respectively. However, it does not tell you that they're equidistant. For them to be equidistant, we need to be shown this on the diagram, that these two segments EF and segments EG, are perpendicular to the chords. So we are saying that if segment EG is congruent to segment EF, then chord CD is congruent to chord EB. Okay. Let's write that down. So we'll say segment AB is congruent to segment CD if and only if EF equals EG. Note we don't have a segment sign. We're saying they are equidistant. That means if EF is 7, then EG must also be 7. Okay, and then you can use this information to work the problems. In circles, center R, segment chord AB is congruent to chord CD, and the measure of AB is 108. So I just want to point out to you so what does it mean when we say measure of arc AB is 108? So what you do is you, from the end points from B and A, no, I wasn't able to go all the way, anyway, did not mean that, so let me try that again. I want to erase that because I didn't want the R there. So let me try this one more time. Okay, that's approximate, but it'll do. I need black, then I need my segment again. Let's try that one. Okay. Oh, well, that's not working, is it? So let's try this. Okay, that's better. And one more time. Ooh, you didn't pick up the segment. Okay, one more time. Okay, so from the endpoints A and B, we drew segments to the center of the circle, which is R. So your central angle is this one, and the measure of arc AB is 108 degrees, which means the measure of this central angle is 108 degrees. I just wanted you to make that connection between the measure of the arc and the central angle. It's subtends. Subtends is a new word for you. Subtends means that if you take the endpoints of that arc, and here is A and B, and you join those points to the center, then the central angle formed thus is called the central angle. So let's take a look at the other problems. Here, 3 props are placed on stage at point P, Q, and R as shown. Describe how to find the location of the table. So it is the same distance from each prop. Think back to the definition of a circle. Look it up. That is a really broad hint. Okay, number 3. Use the diagram circle center C to find the length of segment BF. Tell what theorem you used. I think these you can do on your own, and then you have the answers at the bottom. Okay, good luck.